Welcome to this first video here for proofs. What I want to do is work through the steps of this proof slowly with you so that you can understand what's happening. In the first place, when you're doing a proof like this, you are going to want to draw a vertical line underneath the equal sign, and this is so that you are remembering that this is not an equation to be solved, but that we are going to manipulate the left-hand side. That's what LHS stands for, left-hand side. Manipulate the left-hand side until it looks like the right-hand side. So here what we have is that this left-hand side has an expression that needs to be squared. And when we square it, notice it's just going to follow a polynomial structure that a minus b quantity squared is a squared minus 2ab plus b squared. So this structure right here. Now, next what we're going to do is we're going to rearrange the cosine squared to be next to the sine squared using the fact that addition is commutative. And notice that once they are together, then we are allowed to do a substitution using the Pythagorean identity. We replace sine squared theta plus cosine squared theta with the 1. And then this is going to allow you to now take the 1 minus 1 and allow those to cancel out. They are additive inverses, leaving you just then with the negative 2 sine theta cosine theta, which is the right-hand side. So this is left-hand side equaling right-hand side. This is a different way of presenting a proof. This is an acceptable way of presenting a proof, but on the test I will still be drawing this vertical line underneath the equal sign. Okay, so next we are going to go on to question number 2. Here in this question, what we want to do is recognize that cosecant theta is 1 over sine theta, and tangent theta is sine theta over cosine theta. So we're using the reciprocal identity and also this ratio identity, so two different types of identities. And then we're going to use the distributive property, and once we use the distributive property, the cosine theta is going to take the numerator place here, and then the cosine theta here will cancel with this cosine theta here. So that cancellation, if you do cancellation, remember that you're going to want to use the check marks not crossing through your work so that we don't obscure the work in any sort of way, although the check marks are optional. But once we get down to this step, and notice there are no intermediate steps that need to be shown in between here. This is sufficient for the progress that you need to make on the proof. Then we're going to end up being able to rewrite cosine theta over sine theta as cotangent theta plus sine theta, and so that's the end of that one. All right, now for question number 3, there is no submitted answer for this. I had actually originally done all of these by hand, but it is extremely slow. So I'm going to go ahead and write out the answer to this one and show you. So we want to have a vertical line underneath. Now for each of these, you're going to want to pay attention to the fact whether you have an even function or an odd function. In the case of the even function, the negative will just go away. So we could just rewrite this as cosine of x. But in the case of the odd function, you do need to show pulling the negative out. And this is a commonly skipped step. So what we need to do, and I'm going to color coordinate this just for fun, is we're going to have a negative pop out from here. This is going to come out there, and it's going to show up in your work as a negative here. Notice the parentheses are here to show this intermediate step. And then we have the sine x now without the negative inside. So that now we can show that the negative and a negative make a positive. And so then our final line of work is actually now going to match the right-hand side. But don't skip that step in the middle. You do need to show the use of the even and the odd identities. Okay, so next one. Here we have a fourth power. Now, when you first see this fourth power, you might be intimidated to think that you're going to have to multiply this thing 4 times in a row, but actually you don't. When you see over here on the right-hand side that you have a square, remember that a fourth power is simply a square of a square. So what we want to do then is write the fourth power as the square of a square. And then when you square this binomial, well, it's technically not a polynomial, but it's the polynomial structure of a binomial, then you end up with the polynomial structure of a trinomial. And then as we did in the case of number 1, we rearrange the cosine squared so that it's next to the sine squared. So you have sine squared x plus cosine squared x. These then can be replaced by 1 because it's a Pythagorean identity. And then now you have the right-hand side without having to expand the right-hand side at all. So that's hopefully a lot simpler than you might have expected it to be. All right, next one, number 5. Looks like I'll be doing this one by hand. Okay, so we're going to start by having the vertical line underneath. And you can start on the left-hand side or the right-hand side. You can actually work from both sides. In this case, I see that I have what are called conjugate pairs, where you have 1 minus something, 1 plus something, or rather a minus b, a plus b, the two factors of a difference of squares. So that's a possibility. I might want to consider using that fact. Over here on the right-hand side, I notice that I have a reciprocal and a ratio, so I can try using those as well. And I can look at this from the left-hand side or the right-hand side or work from both sides. So I think I'll do that second option. So then the right-hand side now, we have 1 over cosine x, and then we have a sine over cosine x. And what's nice about that is I can see then what I'm going to end up with, a 1 minus sine x in the numerator with a cosine x in the denominator. So then what that can motivate me to do is to multiply this fraction over here, is multiply by the 1 minus sine x over 1 minus sine x. So then that is going to leave me with a numerator now of 1 minus sine x quantity squared. I'm not going to try to expand that into a trinomial structure because I see that on the right-hand side, I still have this 1 minus sine x intact. There is a square, yes, but I'm going to hope that the denominator can also be written with a square, which I can do. Here I have 1 minus sine x times 1 plus sine x, which is a difference of squares. So that ends up becoming 1 minus sine squared x. So here then I have a 1 minus sine x, still squared, and on the bottom cosine squared x. Now notice I have a square on the top and a square on the bottom, so I actually can rewrite this, and I don't have room down here, so I'll do it over here. I'm going to rewrite this now as the square of 1 minus sine x over cosine x, which is what I get when I combine these fractions up here to have a common denominator. All right, and we'll pick up with question 6 in the next video.